One of the things that we've got to do is find intervals on which a function is continuous. We need to look at endpoint continuity. At an endpoint, the two-sided limit does not exist. So in order to show that a function is continuous at the left end of an interval, we have to show that the function value is equal to the one-sided limit. The same thing holds true for a right endpoint. On a right endpoint, we need to show that the function value is equal to that one-sided limit as well. In this example, we have a picture of g of x, which is an interval from -4 to -2. Let's look at the left endpoint. As x approaches -4 from the right side, we see that it's equal to the function value at -4. However, at the other endpoint, at -2, we can see that the function value at -2 is equal to one value, while the left-sided limit, as x approaches 2 from the left side, equals a different value. So at -2, g of x is not continuous, and at -4 it is continuous. The interval upon which it's continuous is written here, -4 with a square bracket and 2 with a curved bracket, implying that -2 is not part of the interval of continuity. Finding an interval of continuity. Here's a graph that shows the two endpoints. We can say that the graph is continuous on the interval from A to B, including both of the endpoints. Now here's a different graph. We can see that the right endpoint is not continuous, while the left endpoint is. On this interval, the left endpoint is not continuous, while the right one is. We write this interval above. And the last one, the two endpoints, it is not continuous, and so we can write an interval of continuity, A comma B, with curved parentheses on each. In this next example, we have a new graph. Is the function continuous on this interval from -infinity to +infinity? It's discontinuous at the point x equals 0, so we would say it is discontinuous from -infinity to infinity. How about from -infinity to 0, including 0? We say that it is continuous on this interval. In the next interval, we have from 0 to +infinity, not including 0, and we can show that this is continuous.